Hello dear friends, just jump, creep and leap on the subject here. Today I am going to discuss the important concept and give you some important questions on this topic. The work, force and displacement. So stay with me. Alright, let us get started here. Learn every day from everyday life. First, we are going to see the definition of the work. Second, the formulas to calculate work done. And lastly, we will solve top-oriented questions on this topic. I am sure at the end of this video, the concept of work will be really clear and helpful to you. So, what do you really feel? How the work is done? Are you thinking about your homework? Or doing shopping for you? The physics definition of the work is very different from our everyday use. In physics, work is done when there is a force and there is a displacement involved of the object. The formula to calculate work done is force into distance. Therefore, work is equal to force into displacement in the direction of the force. To understand this, let us do a simple experiment together. For that, I need you to get a simple object like a book. So pause to hear this video and go and get the book. So are you ready with your book? I am ready with mine. Now, when you hold the book like this, are you doing any work right now? The answer is no, because there is no displacement of this book. But if you go ahead and lift this book like this, have you done any work? Now the answer is yes, because there is a force involved and the displacement. So you will feel the force when you are lifting the book, and this is your displacement of your work. Suppose in my case, the force is about 10 Newton and the displacement from here to here is 40 centimeter. So how much work I have done? Let us use the formula. Work is equal to force into displacement. So that is 10 Newton into 40 centimeter. Now I need to convert it into SI unit. As 100 centimeter is equal to 1 meter, as 100 centimeter is equal to 1 meter, therefore 40 centimeter is equal to 0.4 meter. So it is 0.4 meter. So I get 10 Newton into 0.4 meter, which is 4 Newton meter. And we know the Newton meter is basically joule, which is the SI unit of the work, as 1 Newton meter is equal to 1 joule. Therefore, 4 Newton meter is equal to 4 joules. So, I have done 4 joules of work right now. Let us put this important formula of this work done on the concept board. Let us place this SI unit of the work done, which is joules. Now see the other case. See the car here. If I drive this car like this, I am doing work. As you can see, force and the displacement are in the same direction here. Now an interesting question is it possible that force and the displacement are in the same direction? What do you think? The answer is yes. Let me show you. Suppose I pull the wooden box like this. As you can see, my force is along the string, but the displacement is along the table. So, there is the angle between the force and the displacement. Now, how we will calculate the work done for this case? So, let us zoom and see. So, as we saw here, the force is along the string and the displacement of the box is along the table here. So, make it easy. Rather than finding the displacement in the direction of the force, we have to find the force in the direction of the displacement. We are going to find out the direction. So for that, I have to consider this right angle triangle here. Here is the right angle triangle. And this is the angle theta here between the force and the displacement. So as you can see, the force is along the hypotenuse of the triangle. But we are interested in finding the force along the displacement or along the base of the right angle triangle. So, what will be the component of the force along the base? That is right. Force into cos theta. So, that will be the work done here. It is going to be force into cos theta into the displacement. So, if I really stand, work is equal to force into displacement into cos theta, where theta is the angle between the force and the displacement. Let us put this formula on this our concept board. The force and the displacement are in the same direction. But the second formula, work is equal to force into displacement into cos theta, is more powerful and worse for any angle between the force and the displacement. Let us see at 3 cases where we can apply the second formula. Case number 1. So, when I push this toy along the table like this, so you can see the force is along the displacement. So, what is the angle between the force and the displacement? It is 0 degree. So, if you use our general formula, work is equal to force into displacement into cos theta. And we know the angle theta is 0. Cos of 0 is 1. So, we get work is equal to force into displacement into 1. That is, work is equal to force into displacement, which is the basic formula. Now see the case number 2. Suppose a person is walking carrying the bag as shown in the picture here. So, to find out the work done, we need to locate the force and the displacement here. So, what is the direction of the force? Since he is holding the bag, the force is enough to hold it vertically upward direction. And the displacement is along the path. And the displacement is along the path he is traveling. Now, what is the angle between the force and the distance he has traveling here? That is right. The angle is 90 degree. Now, let us use our formula. Work is equal to force into displacement into cos theta. And we know the cos 90 is equal to 0. So, the work done actually turns to be 0 in this case. Now, how is it that possible? Is there any other force for which he is doing for non-zero work? The answer is yes. It is the force of the friction. It is the force of friction. So, when he is walking along the path, he is doing non-zero work against the force of friction. There is no friction between the bag and the ground. So, an important exam tip is to find the work done, you need to consider the force involved and the displacement. Case number 3. If I leave the book like this, what is the work done by the force of gravity here? So, last time we have to look that what is the work done by us. But now we are interested in what is the work done by the gravity. So, what is the direction of the force of the gravity? That is right. It is vertically downward because it is the weight of this book. But what was the direction of the displacement here? As you saw, it is vertically upwards. So, the force of gravity and the displacement are here in opposite direction. What is the angle between the force and the displacement? It is not 0 degree. It is 180 degree. Now, put the values in this formula. Work is equal to force into displacement into cos theta. Here, theta is 180 degree. So, cos of 180 degree is minus 1. So, the work done in this case turns out to be negative. Work is equal to minus force into displacement because the force and the displacement are in opposite direction. We have learned here that the work done can be both positive and negative. So let us put all these 3 cases on our concept board. This is our concept board. And I will encourage you to pause here and take down notes. First, work is equal to force into displacement. Second, work is equal to force into displacement into cos theta. Third, SI unit is joule. So the summary is see the three cases. Case number 1. If theta is 0, work is equal to force into displacement. Case number 2. If theta is 90 degree, work is equal to 0. Case number 3. If theta is 180 degree, work is equal to minus force into distance. Work is equal to minus force into displacement. Now we have finished the concept of work. Let us have the top 3 exam oriented questions. Question number 1. A boy lifts up the box of mass 5 kg to height of 150 centimeter. What is the work done by the boy? Answer is, write down first given. Given is force is equal to 5 kg and the displacement is equal to 150 centimeter. First, let us convert the displacement centimeter into meter. As 100 centimeter is equal to 1 meter, therefore 150 centimeter is equal to 1.5 meter. Also, as 1 kg is equal to 9.81 Newton. Therefore, 5 kg is equal to 49.05 Newton. As the boy is lifting the box against gravitational force, the direction of force is downward and the displacement is in upward direction. Hence, the angle between the force and the displacement is 180 degree. Here, the cos theta of 180 degree is minus 1. Now, work is equal to force into displacement into cos theta is equal to 49.05 Newton into 1.5 meter into minus 1 is equal to minus 73.575 Newton meter. Now, as 1 Newton meter is equal to 1 joule, therefore 73.575 Newton meter is equal to 73.575 joules. This is the SI unit. The work is negative against the gravity. Question number 2. Under what conditions the work is 0? Answer. When the angle between the force and the displacement is 90 degree, work will be 0. Because cos theta of 90 degree is 0. Question number 3. Is work a scalar quantity or a vector quantity? Work is a scalar quantity. How? Let us see. Work is the product of force and displacement. W is equal to force F into displacement S. But the force and displacement both are vector quantity. Both of them have magnitude and direction. But the work has no direction. It has only magnitude. Hence, work is the scalar quantity. I will insist you to solve this question. So, I hope the concept of the work is super clear to you now. And do remember, in physics, work is very different from day-to-day life. In this video, we learned that work is equal to force into displacement. There is a second formula to calculate the work done. Second one is work is equal to change in energy. To be specific, that is change in kinetic energy. See it in the next video. Congratulations for concentration. Go ahead. Be continued. Thanks for watching.